8.1 Notes, Kinetics. So some reactions that we look at are very fast, like rocket fuel burning, while others are very slow, like concrete hardening. Now, how fast a reaction occurs is known as the reaction rate, or the change in concentration of a reactant or product per unit time. So when we're thinking about things in rates, you might think of speed. So speed is a rate at which an object can move. And so the units we have for speed are things like meters per second or miles per hour, like your car goes. A reaction can also be the rate of the reaction can be looked at. And when we're talking about reaction rates, what we're going to look at is the concentration that is there, the concentration of a reactant or a product. And one of the abbreviations that we're going to use for concentration are these brackets. So concentration, again, per time, just like in speed. So how fast a reactant is used up or how fast a product is made. So for chemical reactions, it is the average rate at which reactants produce products. And we can think of this like as an example of a peanut butter sandwich being made. So we have our peanut butter and our jelly and our bread. These are the reactants. And when we put them together, we form a product known as the peanut butter jelly sandwich. Of course, looking at chemical examples here, we have the formation of water from hydrogen gas and oxygen gas. So what happens is at the beginning of the reaction, we have a certain amount of hydrogen and a certain amount of oxygen that's going to produce water. And so at the beginning, the start of the reaction, we have lots of the reactants, hydrogen and oxygen, and maybe we have none or at least very little water. And at the end of the reaction then, our reactants have been used up, and so we have very little of that left. And we have product that has been made. So how fast this happens is known as the rate. All right, so reactions occur because the reactants collide together to form the products. And this is outlined in the collision theory. So the collision theory states that atoms, ions, and molecules must collide, and they must collide with sufficient energy, and they must collide in the correct orientation. So these three things have to happen: a collision with energy, and orientation, the correct energy and orientation. So if we look at this example here of these pictures, we only have one that successfully creates products, one successful reaction. And so right here we have products that are being made. So this is a successful collision. All the other ones did not create products, so something was wrong with them. So if we look here at this first one, there is no products that are made. And the reason why, they did collide, but if you look at how this one's oriented correctly, this one is not though. So right here, to create a product, I need these two to be on opposite sides of this one large atom. And so if they collide in this orientation, that can't happen. It needs to collide on this side of it. And so this does not happen. There's no reaction because it is in the wrong orientation. All right, if we look at the next one, also no reaction occurs. And again, the reason why, if we look at the collision, this one, again, is in the wrong orientation. I need this atom to collide on that side of the molecule. So there is, again, no reaction because of the wrong orientation. And finally, this last one, it does collide, and if you look, it actually collides in the correct orientation, but we still don't get products. So there is no reaction, even though there's a correct orientation. So what we can assume then is if there's a collision and it's in the correct orientation, and it did not produce products, then there was not enough energy. So, not enough energy. So, all three things have to occur. You have to collide with sufficient energy and the correct orientation. If you do this, you will have a successful collision, a successful reaction. Now, how fast this reaction occurs, that is kinetics. That's the study of kinetics. And the speed at which reactions can occur is not constant. We can change it. So some reactions are fast while others are slow, but rates are not constant. We can speed up reactions by doing a couple of things. So the reaction rate for almost any chemical reaction can be changed by varying the conditions of the reaction. And conditions that basically increase the reaction rates are going to include anything that increases the number of collisions. Two of the things that we're going to look at, and there are about 6 different ones. We're just going to focus on 2 of these, is concentration and temperature. So reactions will increase if the concentration of the reacting products are increased, and this makes sense. So one of the fundamental principles of the collision theory is that things need to collide. Therefore, the number of particles in a reaction is going to affect the rate at which it occurs. If there are more reactants, they're literally colliding with each other more frequently. So, if I increase my concentration, that is going to increase my reaction rate. The second thing we're going to look at is temperature. So to increase the rate of reaction, you usually need to find a factor that increases the number of collisions. When temperature is raised, what's actually being raised is the kinetic energy of all of the molecules. So if we look at these 2 pictures here I have a low temperature. So what's happening here is I have low kinetic energy. And then when I raise the temperature, the molecules are now moving faster, and so I have a higher kinetic energy. So here we have slow, and here we have fast. If the particles are moving more quickly, then there will be more collisions. Raising the temperature also means that more particles are hitting each other with sufficient collision energy. So not only am I increasing the number of collisions, I'm increasing the energy at which they hit. And so I am actually improving 3 of those factors. So they have to collide with sufficient energy and the correct orientation. So I'm doing both of those. So again, as the temperature increases, the reaction rate will increase. So an increase in temperature means an increase in reaction rate.